Hello, hello. Welcome, guys. I have good news. I have good news. It seems it's a little bit dark, right? It's a little bit dark. I will turn on LED. Just wait. Okay, good. So today, let's talk about transistors. Welcome to the stream. It is 6 a.m. in Korea. We have a browser. This is browser. This is terminal. So let's go to from the transistor. What do you have here? Let's go to the README. Okay. So this table of content is based on George Hot's repository. Machine is 922game.net. Okay. Stream is fine. Stream is fine. Stream is going fine. So we have we have a LAN to game build own feature. We have emulator. We can use emulator. Okay. This is emulator. Let's play this game. Okay. It is actually not emulator, it is simulator, right? Because it's simulating the real world. It is raining outside heavily, but I don't know actually how noisy is it for you. I need to check the noisiness, otherwise I need to close the door. Okay, I updated the bitrate for video. Okay. We have another problem. Okay, we have excellent connection now. Our drop rate is 0. That's good. But I don't know why I cannot see on internet. Yes, now it's working. It's working very good. So here we have a task. Okay. Let me to explain briefly what is a transistor. Okay. So you can see my screen, right? This is screen. So transistor is a switch. Okay. Switch which will make 0 as a 1 or 1 as a 0. When there is input as 1, it can do it. It can return it as 0. Or it can return it as 1. So there is a tricks based on how the circuit works. So if you figure out how to do, like how to pass 1 1 and get the 0, then this problem is called binary problems, binary operations. If you solve binary operations, that's the first stage. That's the first stage that you can now build more complicated computers. So that's also compute. Okay. So here we pass. See here. It is 0 0, right? And we're passing 1 1. And we want to have this output as when we pass 1 1, output should be 0. If we build this kind of circuit, then this is a fundamental one small part, component of our daily life computers. So we have a power, we have two inputs, and we have a condition. Okay, here, this is a challenge. Okay, this is exercise. We need to discover by ourselves, so that we have this condition, and our computer, our program should follow this guy, this feature, okay? This condition. So we have a relay. Relay is, in this case, we can say a relay is equivalent to the transistor, okay? So because it has in, it has out, and it has what is C? A source. Type a source. Type a source. C means for source, right? In. Click the checkbox to toggle the input signal and see how it affects the circuit. Click the checkbox. I think for C we need to put it to the power. Maybe C stands for kind of power. C stands for current, okay. Electric relay by default connects from in to out, but when there is a current on C, it disconnects. When we have a current, and when we have an input, right? Automatically. Look, when there is a current, there is power, it doesn't work. Interesting, right? Interesting. So this is a small part of actual computer. If we want to build a real computer, real hardware, real as a processor, we need to really focus on this first, this binary operations, okay? Okay. We need to return 111, right? 111. Let's start from the back, okay? Here. But which one do we need? Default on or default off? If we put default on, it means by default it passes the input signal to the output. I can only connect one. Look. When we have 1, it should return 0, okay? When we have 1, 0, it should return 1. We need to pass a signal, right? It's not working. No, in should be for input, okay? C should be for power. But we have a power also, right? Look, when there is 1, 0, it should return 1. Am I missing something? Look. Here we need to think carefully, more carefully. If we have a 1 right here, it's pathing, right? We have a signal going. And we want basically this signal to come here. What we can do is like do like this. No? We use this one. Fine, right? But we have a problem. Problem is that we are satisfying this requirement, but we are not satisfying our initial requirement. When we have a 1, 1, it should return 0. When we have an input 1 and this one 1, we need to return 0. This relay doesn't work. This relay works. Look, when we have 1, 1, it should be 0, right? But we are returning 1. And let's replace this one with this guy. To B, C, this guy. Okay, now it's fine. Now we are satisfying 2 requirements, fine. So what's happening? So when we pass 1, 1, we return 1. When we turn off, it works. You know, actually, we can just connect this one to here. I mean, this guy is not necessary. This guy is not necessary. Maybe. No, it is. It seems like it is necessary. Can I connect like? Can I do like this? I mean, instead of 2 things, I can basically. Oh no. It's not good. We need to go back one step back. Okay, now we have satisfied two requirements, but we are missing other two, remaining two. So when they are both 0 and 0, our output should be 1. It means if it is 0 0, it should be 1. You know. In this case, it is 1, it is 0, right? It's 0. But this guy, if it is 0 and 0, 0. 1 and 0 is 0. 1 and 0 is 0. If we have 1 1, this returns 0. If we have 1 1, this returns 1. If I turn off this one. Look, this one always returns 0. Look, when this is 1, this is 0. It doesn't work. It doesn't make sense. In can be connected only to once, right? No, it's not. I mean, can I connect one more time? I mean, this is limit to 1, right? I cannot use twice. Someone is watching some kind of video outside. Let's talk about this one, 0 0 and 1. Okay, so here it means when we didn't do if we didn't pass any signal, any 1 to here and here and here, I want it to be 1. So this should work, right? In order for this to work, we need to pass to in this current, not this guy. We need to pass a current. I'm just guessing. No, it's not that. Look. Maybe we need to use this one. Oh. What if we use this one and for in we connect to here, for this guy to here? Yes, 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 now we know. Now we can just connect this one. Yeah, yeah. Okay, we have 3 passing, guys. Congratulations. Only one left. One left. So here, if we pass this as 0, this as 1, it's not working. So B can be 0 or 1, right? If it is 1, it's not working. Now let's delete, let's refactor, let's refactor. When we have 1, 1, it should be 0, yes. Look, when A is 0. Oh, where is my A? It's bad. It's bad. It's bad. It's bad. We need really understand this. We really understand how this is working. So this is we have one, and these two things can come from one power, from one source. No. Mm-hmm. This is really complicated. When we have a current when it is 1, let's look to this guy, okay. When it has a current 1, and this is 1, it returns 1. This one. This is 0, guys. 0, 0, 0, 0. So let's check it. Look, it's 1, right? If I turn it off 1, 0, 0, 0, 0. C 0 and in 0. Return 0. Okay, now default on relay. Okay, C1 and in 1 return off. Look, default off, right? Default on. If you have power, 0. Guys, now we can see it better, right? We can understand better. We have this 8 cases, okay, 8 cases. 4 and 4. We need one. We need one. I need one more than one. If you use this only one, single one. But it is 0, 0, we need to return 1, right? But we are not doing like that. Okay, hello Chanuka, Hihi Sara. So here, C1 and 1 return 1, right? It is C1 and 1 return 1. Default off. Well, it is 1 and 1, we need 0, right? Let's take this one, okay? Take this one, plug in here, plug in C where? Here and here. Now you can see we solved 2 cases, right? 2 conditions. We satisfy 2 conditions. But how to do the first and third one then? When we have 0 and 0, we have no signal, right? We have no signal coming. If we have no signal coming, we always return 0, 0. But we need to return 1, right? It means when we pass to the current the power, and when we have input 0, it should be 1. Do we have such thing? If our current is 1 and input is 0, it is 0. No. Okay, we have the default on. We can use this one, where if we pass in as 1, it will return 1. Can I use this one? Okay, I am using this. I am giving here 1. And then if I put it here, okay, I can put it here or there, right? If it is 0, 0, we have this one, right? We have a 1, okay? If 0 0, we have a 1, and this 1 should go here. How? We have default off when this is 1 and 1. Okay, this guy is always give 1, okay? So in our case, we are receiving 1 1 1 3 times, right? I can just do like this and satisfy three things. Actually, three things, okay? Here. Let's do like this, okay? I'm satisfying the three things. Last one. When we have 1 1, it should be 0. Okay, we have, what is this one? This is a relay default on. When it returns 0, let's ask ourselves. It returns 0 in three cases. When our input is 0 0, but our input is always 1, so here, this one. Default on will return 0 when input is 1. Input is 1 always for our case, and C is 1. So we need to make sure that this guy is 1, okay? When this guy, these two guys is 1. So when this is 1, this is 1, what gives us 1? Okay, when this is 1, this is 1, it gives us 1. We call it default off. So we bring this one, connect to here, connect to here, connect to here. Okay, guys, congratulations. We satisfy all four conditions, but let's check it. What? Check solution, skip level, check solution. Level successfully completed. Level in logic gates, NAND, invert, add, OR, XOR. Okay, good, text level. So this is how the computer works, this is how the hardware works, guys. It's important to know if you want to really appreciate and if you really want to appreciate the computers, because it's not a decade, right, that we have computers, and there are so many research, so many studies around computer science, that and this computer science become only available, like become like reach its peak after the World War II. So it's not a decade, it's not a century yet, okay, but we have very big progress. So we need to, like, really appreciate, really be thankful for this invitation, for these inventions. So let's go to the next topic. Invert. Your next task is to build an inverter component using the NAND component. From this level on, we don't need to consider the mechanics of underlying switches. While physical NAND gates require a connection to the power source, we don't need to show this on the diagram. All components are considered implicitly connected to the power source. We can now concentrate on the logic input and output. Okay, we build this one. So here we have a condition. Okay, when we have a 0, we need to return 1. When we have a 1, we need to return 0. It means when we have 1, it should be 0. Oh, this one is easy. Actually, I didn't think carefully. I just make it, brute force and fix this. So we have a NAND component, okay? It must be real, okay? I think it is actually working like this. So what was the requirement? The requirement was that if I pass one, A is 1 and B is 1, return 0. A is 0 and B is 1, return 1. A is 0 and B is 0, return 1. A is 1 and B is 0, return 1. Yep. This is our NAND component. So when we give 1 1, it gives 0. When we give 0 0, it gives 1. This result as these conditions and this results. Let's go to the next solution. Next level. The next task is to build the AND gate using only NAND and INF component. Okay, we have now NAND component, INF component. What is INF component? INF component is that when we have a 0, it becomes 1. Where it is 1, it is 0, okay? Now we need to build AND. If it is 0 and 0, return 0. 1 and 0, return 0. 0 and 1, return 0. 1 and 1, return 1. So when we have a 0 0, it should return 0, right? Let's just take this NAND component. So here we have a 0 0, it returns 1. Okay, NAND component and AND component are similar. It returns 3 values, 3 same values. It also returns 3 same values. When it is 1 1, it returns 0, but when it is 1 1, it returns 1. So it means we can always have this signal, and I can put it here. So we will invert this NAND, invert everything in NAND to the AND operations, because we can make a 0 as 1 if we put INF operation, if component 1 0 0 0. Let's do it. Done. Simple. So how we start solving these problems? So we start solving problems by dividing them into small parts and actually writing them in here, like. So now we can definitely clearly see what actually is the conditions. When it is 0 1 1, it will be 0. When it is 0 0, it will be 0 or 1. So yep, next level. Or operation is 0 and 0, return 0. 0 and 1, return 1. 1 and 0, return 1. Right? Yep. 1 and 1, return 1. In NAND component. Oh, see. NAND component is different than OR component, but they all return 3 1 1. Here also 1 1. But here when it is 0 0, instead of returning 1, it returns 0. Okay, we need to replace this one to this one. Okay, let's import this first guy. I can directly connect. It will satisfy our some cases, but we need to satisfy the 0 0 1. Okay, the 0 0 should be 0. I can put invert, but if I put invert right now, it will invert everything. It will invert everything. I have an end. Okay, so let's connect just right now. Okay, we have 2 satisfaction, but when it is 1 1, we need a 0. If I put invert, these 2 guys will satisfy, but these 2 guys will not satisfy. Let's see. See? So now we need to think more. Okay. Delete. What if I choose one more NAND? And then we will have 1 1 0 0. Can I use AND? Nope. Let's put in between. Nope. We need. This solution doesn't work. This solution doesn't work. Okay. We have an AND component. Let's think. We have an AND component. When we have 1 1, it returns 0, right? It gives us 0. But I need, it should be 1. It should be 1. Look. Turn on. It should be 1. I can put inverse to solve this problem. Yes, it is working, but these 2 guys are not working. These guys are working. 2 remaining in between doesn't work. Didn't work. Don't work. We definitely need to use AND, but where? But how? NAND by default they support it, right? Okay, this NAND supports these guys, and we will support these 2 remaining. What? Oh, wow, wow. Too complicated. This is too complicated. When we have 0, 0. Guys, do you have anything to add or any hints or suggestions? So we have NAND, right? When it is 1, 1, it returns. Doing vice versa, right? And I said let's just input inf, and we are done, right? We are done. Yes, we are solving these problems, but we are not solving these two problems. If we use another NAND, this NAND solves these two problems. Can I use AND here? If it is 0 and 1, it returns 0, 0. Ah. Okay, let's do like this. And NAND will be the last one, okay? I mean, like, last component to connect to the output. It returns 3, 1, okay? But when we give 1 and 1, it's not returning. Let's give AND. So when it is 1 and 1, our output should be 1. For this one to be 1 in NAND, one of them should be 0. We did something like this. No, 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 no. When we have 0 and 0, we need a 0. No. This guy should be 0, 0, okay? This guy should be 1, 1. Oh, we could. Yes, that's right. That's right. That's definitely right. Because if we put inverse, if we put 2 inverse, we can solve this OR problem. Smart. Simple, smart. I like these kind of solutions. Check solution. Next level. Oh, last level. Okay. Last level, it is 708. I need to go to work now. Anyway, so XOR. I hope I am pronouncing things very correctly. If not, sorry for my accent. So here we have XOR operation. If we build these operations, we can then easily build calculator or calculator stuffs. So here, it is vice versa of OR, right? No, just wait. If it is 0 and 0, return what? 0. If it is 0 and 1, return what? 1. 1 and 0, return 1. 1 and 1, return what? 0. Okay, that's our task. One, two, three, four components. Okay, which of them are really close to the XOR? Return 0, 0. All right. All right. If it is OR, then all right. Okay. Yep. Done. Except one condition. 3 conditions are done, except one. Okay. So when we have a 1, 1, we need to have a 0. Yeah. When we have 1 and 1, it needs to be 0. But by default in OR, if it is 1 and 1, it returns 1. Okay. Then before this OR, let's put a condition here that we will say that if it is 1 and 1, we will return 0. it is 1 and 1, we need to return 0. Invert. No? No, we broke something. When it is 1 and 1, look, when it is 1 and 1, we need a 0. In order to get 0 here, one of this guy should be 0. Okay. I can pass this guy. No, this is OR operation, right? So it means both of them need to be 0. Okay, see? Both of them need to be 0. It is bullshit. So here 0. Yeah, we need 1 and 1. Only if in OR we need to make both of them 0. 0 when these are 1 1. Okay. What about if we delete this or we just include NAND? Let's try this second way. Okay, this is another reverse of our thing, our case. So is here we are satisfying 3, yes, but in the input when it is 0 and 0, we need 1. We need 0, but it is 1. This works, yes, but what about if it's N? If you use AND, then it is reversed. It's fine. Two guys, right? Two things. The simple thing is in this NAND, right? Anyway, NAND. Okay. Guys, do you have any hints? Any idea? Any suggestions? So, oh yes, already satisfies 3 conditions, you know. And now we need to make sure that this guy is working. Look. 0, 0, not 1. 0, 0, 0. It means we need to pass, make it 1, 1. Look, if it is both of 0, 0, we will give a 0. We will get the 0, right? We will get a 0, right? Yes. Okay, for NAND, we said in order to have output 0, we need to have A as 1, B as 1. No. When the 0, 0, we need a 0, right? So another case. When NAND will return 0? Only when A is 1 and B is 1. So when I have 0, 0, we need to make these guys 1. If I use OR, when I have 0, 0, it's 1. If it is 0 and 0, we need a 1. Do we have it like this? Yes, we have. We need to have a NAND. Oh, it's 7:22. Yeah, guys. We need to fix the last one. So we have a 0, 0. In NAND when it is 0. When both of them 1, 1, right? We can satisfy it with this one, and then we can just put NAND, NAND. I'll just add. No, 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 no. Instead of n, then okay. We have 0, right? When okay, this is satisfying, right? But when we have one of them 1, let's return 1, right? It means we need the OR. See? No? Okay, I'm stuck here. I'm stuck. Okay. When we have A0, B1, we need the 1, right? We need to return 1. If, I mean, we need to use OR anyway. This is done, yeah. No, I'm stuck, guys, we need to fix, we need to really fix. Again. When we have a 0, 0, we need a 0. When we have a 1, 1, we need a 0. I have no idea except this guy. It's simple, simplest one. Done. I mean, like, this is what I can do now. This is satisfying, but it is not satisfying with one condition. It is when it is 0, 0, we need a 0. Okay, hello, hello, hello. Let's fix this bug. Not. Let's fix this task. So here we have or, then, or. When we have a 0, 0. When we have a 0, 0, it becomes 1, 1, 1, 1. Okay, 9 returns 0 when these are both of them are 1. Okay. If I add here and if it is 1, it's 0, right? Then it will be 0. If I connect and it will not work. It is working, yes, but it is working for two cases. So here and is not necessary. So here we have nan. When we have 1, 1, we need to have a 0, right? When one of them is working, both of them are working. When both of them 1, 1, maybe we need here inverse, no? Wow, no. Let's sing one more time. What happened? If I add and from NAND, we will always have what? 1 1 1 1 1 1 1 1 0 0. Okay. Look, when we have 0 0, we need a 0, right? We can use AND here. Look, this guy will return 1 only when this is 1. Look. Okay, look. Now maybe we fixed it. So when we have 0 0, we need to have a 0, right? 1 1. How to have a from 1 1 0? Import one more name. Oh no. It's working, yes, but not for all case. Don't I need to replace this? Like here, we need this to have a 0, right? No. We need to have, we need to allow. Look. When we have 1 and 1, When we have 0, we have 1 and 1, right? What? Do you see something? What happened? We fixed it, but I don't know how we fixed it. Okay, what we did, I have a and I have inverse of and. I just take or, and I just give the in. Oh, we have another level. Okay, guys, it's time. It's I think 1.5 hour of stream. It is 7:38 a.m. That's enough for today. Let's continue tomorrow. Because I need to go to work, guys. Have a good, lovely day. Be productive. Push your limits. Study hard. Work hard. And enjoy your life. Enjoy your day. Thank you very much. Bye bye.